This is problem number 4 from section 3.3. It says solve, write the answer in standard form. I'm going to put standard form back up here. We know standard form looks like that. But they want us to solve this quadratic. Now we have to identify how to solve the quadratic. Okay, we've got numerous ways to solve the quadratic, starting with factoring. Actually, technically square roots. I probably should have this as number 1, but square roots we're going to look at first, then factoring, and then if we can't, we'll use a quadratic equation. Let's look at the square root method. I see a term of x squared. Do I see any other terms in here with x? I do, but I also see that it's x squared. So actually, the square root method is going to work because I can subtract the 5x squared over, and combine it with this one, and now I can just use the square root method. So that's how we're going to start this problem, is we're going to subtract out the 5x squared. That gives you 2x squared plus 1 equals 0. Remember, anytime you solve a quadratic, you want to get it equal to 0 so you can find the zeros, right? In this situation, you're going to see that we're going to end up with complex numbers, which makes sense because we're in that section. But we're going to subtract the 1. We get 2x squared equals negative 1. Now we'll divide by 2 on each side. X squared equals negative 1/2. And you can see right here, this is why we get a complex number for the answers, because we're going to take the square root of each side. So square root of x squared is going to equal the plus and minus square root of negative 1/2. So this is going to give you x equals plus and minus. Now, whenever you take the root of a negative, this is where the I part comes in. We're going to write this as plus and minus because we're doing the root of, technically in here, this would be, I'll write this up here, root negative 1/2 is equal to root negative 1 times root 1/2. Right? Those are the same things. Okay, so root negative 1 times root of 1/2, same thing. Well, we know that root negative 1 is I, right? And you can pull up what we know from before with complex numbers. Root negative 1 is I. So we can write that as I root 1/2. And then they might even want us to essentially root 1/2. They usually don't like inside of a radical just a fraction. So we can actually rationalize the denominator is what it's called. So let's do that here. I'm going to move some stuff out of the way. And we'll say that this is equal to plus and minus I root 1 over root 2. Well, I know root of 1, right, because I split the radical. I know root of 1 is just 1, so it's plus and minus I 1 over root 2. I can multiply this by root 2 over root 2. Right? This doesn't change anything. This root 2 over root 2 is 1, but when I multiply the denominator of root 2 times root 2, I get 2. So I end up with plus and minus. On top, 1 times root 2 is root 2. Over, on the bottom, don't forget the I. On the bottom, I end up with root 2 times root 2, which is 2. And so I can finally finish that up by saying equals plus and minus I root 2 over 2. Now I would like you to split this, so you can say this is x equals I root 2 over 2, or x equals negative I root 2 over 2. I always like that you split up the answers so that you know that there are two different answers. Hopefully that makes some sense.